morning, pre-calc fans, on this fine, sunny, bright Wednesday morning. Yes, it is Wednesday morning. We start losing track of days as we are out of our routine. Yes, it is Wednesday morning already. It's a beautiful sunny day out there. Don't let the sunshine fool you though, because it's a little chilly out there. Weatherman said it's going to be like that the rest of the week, so get ready. Hopefully by next week we'll start getting some warmer weather. Hope everything's going well with you and your family. Hope you're staying illness-free, sickness-free. Once again, remember to keep your social distancing. Let's get ourselves back to normal as quickly as possible. Okay, I miss you guys. I wish you were sitting in pre-calc class right now. I know you may be saying, nah, this is okay. But I wish you were here in a pre-calc classroom right now, so we're not going through this. Today what we're going to do is going to go through some review problems. So if you want to download and print off, you can do these, work through these review problems. I also put a sort of review sheet on there. Tomorrow I will post an evaluation for you to be able to do, and that will be due on Friday. This will be the last that we will have in regards to the material this week. Next week we'll get into some trig values and do some trig values and inverse trig values. And that will be next week's topic. But today we'll just do some review problems in regards to how we can do our conversions, deal with our radians, deal with our degrees. Also there's problems on the review sheet. Make sure you go through the review sheet and the problems we've had there. Once again, when we're converting radians to degrees, we have pi over 180 is equal to x radians over theta degrees. We have 250 degrees there, so this will go to pi over 180 is equal to x over 250. Now I want you to leave things in terms of pi. Okay, so we want to leave things in terms of pi. We cross multiply. So we cross multiply. This gives us 250 pi over 180 is equal to x. We can cancel out our zeros. So we have 25 pi over 18 is equal to x radians. Can we take anything out of 25 and 18? I don't think we can. So that's the number of radians we have, 25 pi over our value of 18 radians. When we're converting into degrees, and we have the value of pi there. Once again, it's nice when we have this value of pi here, because this pi is equal to 180 degrees. So we could do our substitution there where we have 4 times 180, and we want to divide that by pi. So if we do our multiplication, let's see that 0. We have 4 times 180, so we have 180 divided by 5, that's 36. So we have 4 times 36, which is 24, carry the 2. 144 degrees. So when we have the value of pi there, it's okay. But when we don't have the value of pi and we just have 7 radians there, we have 7 radians. We want to see how many degrees is in 7 radians. We still go back to our pi over 180 is equal to 7 over theta. But now we don't have this pi to substitute the value in for, 180 in for. So we still want to cross multiply. We are still solving a proportion. So we have theta times pi is equal to 7 times 180. And to solve for theta, what do we have to do to both sides? Well, we're going to divide by our value of pi. So those cancel out. So with our calculator, we can get an approximate value. And once again, this will be an approximate value. It won't be exact value. We can multiply 7 times our 180 and divide by our value of pi. So we have 7 times 180, and we can divide this by our value of pi. and we come up with 401.1 degrees. Now, this is an approximate value. It's not an exact value because pi is an irrational number, but we can get an approximate value. Let's see here. We have a circle with a mass, a radius of 20 inches. Central angle of 220 degrees is drawn. What's the arc length and area of the sector? So as always, what do we need to do? We need to draw a picture, draw a picture, draw a picture. So let's draw a picture of our circle. Whoa, that was crazy. Make it a little bit bigger. There we go. So we have a circle, and the radius of the circle is 20 degrees, and we have an angle which is 220 degrees. So I'm going to finish that angle here. This is 220 degrees. We have a radius of 20 inches, and we want to find what the arc length is. What the arc length is, and then the area of the sector. So if we go back into our notes of what we did a couple days ago, what we did is we looked at the idea of a fractional part. We can look at the circumference of this circle. The circumference of the circle is calculated by 2 times pi times our radius. Our radius is 20 inches, so we have 2 pi times our 20. So we have 40 pi inches. That's in the entire area of the circle. Now we want to find just our arc length, which is a fractional part of the entire circle. Well, what fraction do we have? Well, we have 220 degrees of the 360. So our fractional part is 220 degrees of the entire 360 degrees. Now if I wanted to, I could reduce that down. Let's see, zeros go bye-bye. I could take a 2 out of these. We have 11 out of 18 this fraction reduces down to. So to find this arc length here, our arc length is our fractional part times the entire circumference of the circle. So we're looking at the arc length as our fractional part, 11 pi, or 11 over 18, times our entire circumference, which is 40 pi. Once again, this is fractional part times the circumference of the circle. So if we want to, we can clickety-clack that through our calculator. We have 11 times 40 pi, and we're going to divide that by 18, and we get 76.79 inches. Make sure you get your units there. Make sure you deal with your units, 76.79 inches. Now the area of the sector, now we're trying to find what this area is right here. So now we're talking about the area of the circle. Well, the area of the circle is calculated by pi times our radius squared. Our radius once again is 20, so we have pi times 20 squared. This will give us 400 pi inches squared. That's the entire area of the circle. And once again, we can take our fractional part. What is our fractional part? Our fractional part from up above, area of this sector. Our fractional part times the area of the circle. Our fractional part is 11 over 18. times 400 pi. So we can take our 11 times 400 pi divided by 18, and we get 776.94, or 767.94 inches squared. That would be the amount of area in this circle. There are formulas, once again, that deal with the idea of radians. I like to keep it as simple as possible in regards to our fractional parts. Last one, a 10-inch string. A 10-inch string is used to swirl mass at 5 revolutions in 20 seconds. So basically what you have here is you have a string and you have a mass, and you're twirling this mass around at 20 revolutions per, 5 revolutions in 20 seconds. We want to find the angular velocity and the linear velocity, and this angular velocity is in radians per second. So once again, if we take a look at our circle, we have this mass, and we have a radius of 10 inches in our string. Now this mass is being, we have 5 revolutions. So it's going around and it's going in 20 seconds. Well, the question is, what is our angular velocity in radians? Well, we have 5 revolutions and we have to convert this into radians. And how we did that yesterday? Our 5 revolutions, 1 revolution is equal to 2 pi radians, which is 360 degrees. Just going back to the idea of 360 degrees. And this is, once again, we had to deal with things in radians because degrees fall apart here. So we're going to deal with things in radians. So if I have 1 revolution is 2 pi radians, how many radians would be 5 revolutions? Well, each revolution is 2 pi. So if I multiply this by 5, what we have is 10 pi radians. 10 pi radians. So we have 5 revolutions is equal to 10 pi radians. Well, to find this angular velocity, we just say how many radians do we have and how long does it take? It's the number of radians per second. So we have 10 pi radians in a total of 20 seconds. Well, the 20 and 10 reduced down to give me 0.5 pi radians per second, or 1/2 pi radians per second. Or we could have that as pi over 2. You could write it any way you want. You can write this as pi over 2 radians per second. That would be fine. Or 1/2 pi radians per second. That would be fine. Now to find the linear velocity, what we did is find our linear velocity. We just take our radius and multiply it by our angular velocity. Our radius is 10 inches, so we have 10 inches times this pi over 2 radians per second. If we multiply this out, this gives me 5 inches per second. 5 inches per second. There's a couple of degree minutes seconds on there also, so make sure you look back on our notes with the degree minutes seconds, and also you can look at the worksheet I gave you and the solutions to that to give us the degree minutes seconds also. So you'll have a few problems that deal with degree minutes seconds. I posted a solution to them. There's additional problems on there. You don't have to worry about the additional problems. on the evaluation tomorrow and Friday, but there were just some trig values that we will be working on next week. I just cut down a review sheet that we had from before. I'm not going to redo a review sheet. It's the exact same problems. So you can check the problems that are on the review sheet. The Word document that's a word sheet, the review sheet, that's what you'll be responsible for. Like I said, there's additional problems on the review sheet. Don't worry about the additional problems. We'll be dealing with those additional problems next week. Other than that, I have nothing else for you. I will post things tomorrow in regards for you to get an evaluation this week. Make sure that you are, pushing yourself through the material, and we'll be fine. I hope everything's once again is going well. Hope everything's going well with you. Hopefully we can get back to some sort of normalcy here soon. I miss you guys. I wish you were sitting here in class, but it's our new reality. That's fine. Please make your effort, make things, get things taken care of, and take care of your educational responsibility. Other than that, I have nothing else for you. Enjoy maybe some sunshine. Hopefully you can sit in the sun a little bit, at least in your house, and you can feel the warmth from the sun. Other than that, adios. I'm out here. See you tomorrow.